Alright, so let's look at this question here, which is on graphing techniques, taken from the year 2022 paper on question 10 of the H2 math paper. So a curve C has this equation here, and we are given that A is bigger than 0, and B is not equal to negative half A, and X is not equal to 1. Given that C has no stationary point, use differentiation to find the relationship between A and B. I think no stationary point is pretty straightforward, meaning to say dy dx has no real solution. Right, so this case here, what I'm going to do is actually just dy dx it. So y-ax plus b plus, this is a constant a plus 2b, then after which I'm going to get x minus 1, negative 1. So dy dx could be a plus negative 1, a plus 2b, x minus 1, minus 2. Okay, so what I'm going to do is actually just a stationary value. dy dx is equal to 0. So this case here, what I'm going to do is just solve for my x, right? So this is a minus a plus 2b over x minus 1 square equals to 0. Bring over the other side a plus 2b. Okay, then we're going to just a plus 2b here. Then I'm going to result in the, what do you call it, in the quadratic equation. Now what we are supposed to find, you're supposed to find that you won't have any real solution here. So you want to have no real solution. So I'm going to just multiply above the x minus 1 square, a plus 2b. So this is a x square minus 2x plus 1. Then I'm going to just simplify everything. Okay. So once I expand everything, I could simplify this as a x squared minus 2a x minus 2b. So since no stationary value, it just means no real solution. No real solution for this equation. Okay, so discriminant d is less than 0. So in this case here, b squared minus 4ac is less than 0. So there you go, this is it. What we need is this. So I'm gonna just this is 4a squared. We factorize it out. Then this is plus 8. Maybe I just put this 4a to, because I could factorize the 4a out. So I'm a bit, so this case I'm gonna just put 4a. There you go. So this is 4a multiplied by a plus 2b is less than 0. It has to be negative. But we were told that a is positive. So since a is positive, you know for sure that this has to be negative. Okay, because this is always positive. A is always positive. So this will then be a is negative. This case here. Then this will imply that a plus 2b is less than 0. So that's how I'll solve for part A. Let's look at part B. So it is now given that b is minus 2a. Sketch C. So we're just going to replace b as minus 2a in it, right? Then we just try and sketch a curve. So first thing is, if I were to replace b as minus 2a, I think it's not hard to get this, right? So this firstly, what we get is actually, this is the oblique asymptote, which is y equals to ax minus 2a. Then after which the vertical asymptote is where we will have x equals to 1, right? It can't be divided by 0. And the first thing is to understand that for rational function, what I usually tell my students to do is just draw the vertical asymptote and also the oblique asymptote first. You make your axis, you draw your x and y axis later. So essentially what I'm saying is you just draw x equals to 1. Doesn't matter because you can adjust the axis later, right? So we just draw this out. Then I know that this is x equals to 1. Then after which I have got ax here. This guy. Okay. And this guy. Then what we have is the oblique asymptote, which is y equals to ax minus 2a. It's good if we could just find out what is this point here. This is when x equals to 1, so it's 1. When you replace 1 in it, so it's a1 minus 2a, so it's 1 minus a, right? So it's a negative value there, right? So that's the first thing. Then after which what we can do is, this is 1 negative a, Just label this out. Okay, then after which what we can do is just replace any value of a which is positive into a GC and try and sketch it. So in this case, I let a be 2. I key in my calculator, then you just let a be 2 or any kind of value, then just generally see what is the graph going to look like. So this is a equals to 2, just key this in, and I'll get this value here. This graph is such. So what we're going to do is just, I'm going to draw the graph here. So here, draw it up. Then after which you draw this side down. Okay, then after which you can draw the axis in. So the axis will be here. There's a small corner here which we need to draw later. So I'm gonna draw. I think this is not too bad because I think x is 1, so y-axis will be on the right side of x equals to 1, the vertical line x equals to 1. Then after which we have got, this is a is positive, right? So this point here will be below the x-axis. Okay, so here, so this would fit the bill as such. Okay, so maybe I just put it here as such. Okay, that's right. I'm gonna fill in the rest. So this is this guy will be 0, so is minus 2a. We can find this intercept here. Then this is y. So when x equals to 0, y is equals to 0 minus 2a minus 3a over minus 1. So that will be a. So in this case, it will be 0 comma a. Okay. Then this guy here, 0 comma a. This guy here is, we need to find when y is 0. There are two values here. So it's a key. We can just write y equals 0. Then solve this, right? So it's y0 equals to ax minus 2a minus 3a. You can see that actually what we can do is just divide by a throughout because the a could be factorized, right? So a, okay, maybe I just multiply by x minus 1 divided by a. Because the a is more than 0, it's not a solution, so you can cancel it away. So since a is bigger than 0, so this case here, what I can do is just multiply x minus, so 0 equals to x minus 2. I cancel a away, minus 3. Okay, so once we're done, we can just expand this. 3x plus 2 minus 3 equals 0. 0 equals to x squared minus 3x minus 1. Then key in calculator. So essentially it's independent of a. So it's good because what we could do is now just key in calculator, then we just go to the 0. We search for the intersection point here. And then you get this value here. Okay, so it should correspond to this. So this means it's correct. So this guy will be negative 0.303 comma 0. This guy here will be 3.30 comma 0. Okay, so then you just label the rest. So when y is 0, this asymptote here will cut at 2. Okay, so I just label this down nicely. Anything else I need to take note of? I think that's about it. So let's look at part C. On the same axis, sketch a graph of y equals to ax minus a. So this is ax minus 2a. So ax minus a will be the same line but being translated by a units. Sorry. So this is minus 2a. So a units will mean that this is like half of it. So this guy, I'm going to use my orange color. That's minus a. Then this guy, I think is y equals to ax minus a. So when y is 0, x is 1. So this will be, oh, you cut here. A 1. This is just 1. Okay. You'll need to cut here, okay? You'll need to cut here because it cuts through 1 here. It's just nice. So, yep. Or you could just plot in your GC. You'll be able to see. Okay, so we're gonna ax. So my a is 2, right? 2x minus 2. Cut through 1 here. Okay, so just be mindful of that. Now once done, C is done, then let's look at the last part. So for D, hence solve the inequality for x minus 2 and then 3 minus 3 x minus 1 and less than x minus 1. You could see actually to get from here to here, okay, actually from the previous equation, let's look at C when b is minus 2a. I'm going to look at that equation there. So from here, what we could do is actually you realize that when you need to solve this inequality, this is somewhat similar to C, right? The curve C. So this is when a is equals to 1. You can see that a is equals to 1 here. Okay. Similarly for this guy here, this is also when a equals to 1. Both of it. So this is a line of y ax minus a when a equals to 1. This is C, curve C when a equals to 1. Okay, so essentially what we do is we just need to sketch the curve here using a equals to 1. Just now I use a equals to 2. Then what we need to do is just find the intersection curve here. Okay, where a is equals to 1. That's about it. And we need the curve to be smaller than the line. So the curve is smaller than a line here to here, and also below the line which is here. Okay, just look at that. We're going to change the value here is 1. Then this guy here is also actually just key in the equation there, 3. That is x minus 1. You say, what's the point of plotting the graph? Because the reason why you need to plot the graph is because you can't really see the what do you call it, the horizontal asymptote and the vertical asymptote. That's why it's important. So this is minus 2, negative 3. So you from GC they intersect at from GC curve and line intersect at negative 3. So essentially what you want is the curve to be below. So the curve is below here and also curve is below here. Right, the curve is below the line here. So it will be the solution. Hence solution. Do you want solution set? So okay, so the solution will be x or x more than 1. Okay, because what we want is we can't equals to 1 here, but we can equals to 2 here. So at most negative 2 and then more than 1 can't equals to 1. Okay, so that's how we do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.